In this lecture, we will continue our discussion on particular solutions of linear recurrence solution with constant coefficients. So this is a kth order linear recurrence solution with constant coefficients with function fr in the right hand side. So when fr is of the form, this is the form of the function fr. Okay. The corresponding particular solution will be of the form. So this is the corresponding particular solution. So only difference is that here beta is a characteristic root of multiplicity m of the difference equation. Then you have to multiply r to the power m, okay, in the particular solution. So come to an example here. Let's suppose fr is of the form 3r plus 5 into 3 to the power r, okay, where 3 is a characteristic root of multiplicity suppose 2. Then the particular solution will be of the form, so here in the place of m you have to put 2, so this r square into, this is the polynomial of degree 1, so it can be written as p1r plus p2 into 3 to the power. So this is the particular solution. Come to another example. You suppose fr is of the form 6 into 2 to the power r, okay, where 2 is a characteristic root of multiplicity suppose 3. Then the particular solution will be of the form r to the power 3, okay. So this is a 0 degree polynomial, so we can write a single constant p into 2 to the power r, okay. Come to example 1. So here we have a difference equation of order 1 and we have a polynomial of degree 0 on the right hand side with 2 to the power r, okay. So the characteristic equation, so let me give equation 1 here. So the characteristic equation is alpha minus 2 is equal to 0, which implies alpha is equal to 2. So this alpha is equal to 2, that is the root of this characteristic equation is equal to this beta, okay. So 2 is a characteristic root of multiplicity 1, because there is only one root of this particular characteristic equation, okay. So the particular solution will be of the form r to the power 1, that is 1. This is a polynomial of degree 0, so single constants p and 2 to the power r. So this is the form of the particular solution, okay. Put 2 in 1, get r into p 2 to the power r minus 2 into r minus 1 into p into 2 to the power r minus 1 is equal to 3 into 2 to the power r. Now let us solve this one. R into p into 2 to the power r minus, so this is 2 into open bracket here, this will be r into p into 2 to the power r minus 1, r into p into 2 to the power r minus 1 minus p into 2 into r to the power minus 1. Okay, so this is r into p into 2 to the power r minus, now multiply this 2 here, so we get 2 into 2 to the power minus 1 is 2 to the power r, so we have r into p into 2 to the power r plus 2 minus 2 into this minus is plus, so this is equal to p into, so this is 2 to the power r is equal to 3 into 2 to the power r. Okay, so this cancel out, so we have p into 2 to the power r is equal to 3 into 2 to the power r. Okay, now let us get this equation 3, comparing both sides of 3, we get, so when you compare this one, so we get p is equal to 3. Okay, therefore the particular solution p is of the form r into p into 2 to the power r, this implies arp is equal to, we got the value p is 3, so we get 3 into r into 2 to the power r. Okay, so this is the particular solution we get here, and this is the answer. Come to example 2. So find the total solution for the difference equation. So this is a second order difference equation. With right hand side we have a polynomial of degree 1 and 2 to the power r that is multiplied with the polynomial. Okay, so let us write down the difference equation first. This is ar minus 4 ar minus 1 plus 4 ar minus 2 is equal to r plus 1 to the power r. So this is equation 1. Now the corresponding characteristic equation is alpha square minus 4 alpha plus 4 is equal to 0. So this is the corresponding characteristic equation. Okay, now solve this one. So we get this one is alpha minus 2 whole square equal to 0. This implies alpha is equal to 2, 2. Okay, so here 2 is a characteristic root of multiplicity 2. Okay, because here 2 is repeated twice, so the particular solution of the form so we can write r square. Okay, because here the root 2 is repeated twice, so we have to use r to the power m. Here m is 2, so r square p1 r plus p2. So this is for this polynomial of degree 1, so I have to write p1 r plus p2 into 2 to the power r. Okay, now substitute 2 in the left hand side of 1, we get, okay, so we substitute this particular 2 in the left hand side of this equation 1, so we'll get r square p1 r sorry p2 2 to the power r. Okay, so this is for this AR term. Next we have minus 4 r minus 1 square p1 r minus 1 plus p2 plus p2, okay, into 2 to the power r minus 1 plus 4 for the last term, 4 r minus 2 whole square p1 r minus 2 plus p2 2 to the power r minus 2. Okay, so now let us simplify this one. So this is equal to r square p1 r plus p2 2 to the power r. Now let us use the formula a minus b whole square. So we get r square minus 2r plus 1 and multiply this p1 with r minus 1. So we'll get p1r minus p1 plus p2 into 2 to the power r minus 1. Okay, similarly use the formula a minus b whole square. So we'll get r square minus 4r plus 4. So this is p1r minus 2p1 plus p2, this p2, then 2 to the power r minus 2. Okay, so let us simplify more. Now let us bring back here this 2 to the power r minus 1 is multiplied with this 2 term, so we can bring it back here. It is 4 into 2 to the power r minus 1. Okay, now multiply these 2 terms. So we'll get multiply r square with first with this term. So we'll get p1r cube minus p1r square plus p2r square minus 2p1r square plus 2p1r minus 2p2r plus, now multiply 1 with this, so we'll get p1r minus p1 plus p2. Okay, so this term is multiplied with this term and we obtain this. Okay, similarly here we'll get this is plus 4. So this is 2 to the power r minus 2, we'll bring back here. This is 2 to the power r minus 2. So this one is p1 r cube minus 2p1 r square plus p2 r square minus 4p1 r square plus 8p1 r minus 4p2 r plus 4p1 r minus 8p1 plus 4p2. Okay, so in the last term 4 is multiplied with this term, we get 4p1r minus 8p1 plus 4p2. Okay, now let us more simplify this. So we'll get, so let us bring back here. So this is 2 to the power r, multiply this r square with this term, we'll get p1 r cube plus p2 r square. Okay, now this is 2 to the power r minus 1, this is equal to 2 to the power r divided by 2. So 2 and 4 will cancel out, it will become 2 into 2 to the power r. Okay, then we have, let us simplify this one. So only one p1 r cube is there, so write it down here, p1 r cube. Okay, minus p1 r square minus 2 p1 r square is equal to minus 3 p1 r square. In the same manner, simplify other terms, so we get 2p2r minus p1 plus p2. In the same manner, it will be 2 to the power r divided by 4. 4 will be cancelled out, we have only 2 to the power r. Okay, now simplify this particular term, we get p1 r cube minus 6 p1 r square plus p2 r square plus 12 p1 r minus 4 p2 r minus 8 p1 plus 4 p2. Okay, now take 2 to the power r is common in all the term. 2 to the power r is taken as common, so we'll get p1 r cube plus p2 r square minus 2 p1 r cube plus 6 p1 r square minus 2 p2 r square minus 6 p1 r plus 4 p2 r plus 2 p1 minus 2 p2 plus p1 r cube minus 6 p1 r square plus p2 r square plus 12 p1 r minus 4 p2 r minus 8 p1 plus 4 p2. Okay, so now see here, we have this p1 r cube is cancelled out with this p1 r cube, 2 p1 r cube is cancelled out with this 2 p1 r cube. Okay, and p2 r square. Okay, this p2 r square, we have this p2 r square is cancelled out. Okay, so let me check once again. Okay, sorry, so we have slightly have this mistake here. So this p1 r cube is plus p1 r cube and this is minus 2 p1, that is cancel out. Okay, so now this p1 p2 r square, this is plus p2 r square, that will be cancelled out with minus 2 p2 r square. Okay, now next we have plus 6p1 r square. Okay, this is minus 6p1 r square, so this is cancelled out. Okay, and the remaining terms are so the remaining terms are the remaining terms, so you can write it down, the remaining terms as okay, so one more cancellation is there. This is 4p2r minus 4p2r, so this is cancelled out. Okay, so we have remaining terms, we can write it down. So remaining terms can be written down as 2 to the power r. Okay, so this is minus 6p1r plus 12p1r is 6p1r. Okay, so this is complete. Now come to plus 2p1 and minus 8p1 is minus 6p1. Okay, so this is also complete. Now minus 2p2 plus 4p2 is 2p2. Okay, so it can be written as 2 to the power r 2 to the power r 6p1r plus 2p2 minus 6p1. Okay, so let it be 3. So compare 3 with the right hand side of 1. We get okay, so we'll compare this one with the right hand side of 1. Okay, so we'll get the right hand side of 1 is this, so we can compare with this one. So we'll get 6p1 is equal to 1 and minus 6, this one minus 6p1 plus 2p2 minus 6p1 plus 2p2 is equal to 1. Okay, so see here we have this characteristic equation, we have 2 to the power r. Okay, so here the coefficient of r is 1 and constant term is 1. Coefficient of r is 1 and the constant term is 1. So here the coefficient of r, this 6p1, that is equal to 1, and this constant term is equal to 1. Okay, now let us solve this one. So we have 6p1 is equal to 1, so p1 is equal to 1 by 6. Okay, now we'll get substitute p1 here, we get minus 6 into 1 by 6 plus 2p2 is equal to 1, which implies cancel out. Minus 1 plus 2p2 is equal to 1, which implies 2p2 is equal to 2 and p2 is equal to 1. Okay, so hence the particular solution is of the form ARP is equal to, we know the particular solution will be of the form r square plus p1r plus p2 into 2 to the power r. Okay, put the value here, value of p1 and p2, so we'll get r square, value of p1 is 1 by 6, so r by 6 plus value of p2 is 1. Okay, so this is the particular solution for the reconciliation. Okay, come to example 3. So this is a second order difference equation and with the right hand side is equal to 2 to the power r plus r. So see here, this example 3 is slightly different. Here r is not multiplied with 2 to the power r, but here r is added with 2 to the power r. Okay, so slightly the particular solution will be different. So let us first write down the equation first. So we have ar minus 5ar minus 1 plus 6ar minus 2 is equal to 2 to the power r plus r. Let be equation 1. Okay, corresponding characteristic equation is alpha square minus 5 alpha plus 6 is equal to 0. So let us factorize this one. So we'll get alpha square minus 5 alpha can be written as 3 alpha minus 2 alpha plus 6 is equal to 0. So this one is common here. So we'll get, so this is alpha minus 3 alpha minus 2 is equal to 0. So alpha is equal to 2 comma 3. So these are the roots of the characteristic equation 2 and 3. See here 2 is same as here beta. Okay, so we can say 2 is the characteristic root of multiplicity 1, because 2 is repeated only 1. Okay, and there is no use of 3 here. Okay, so general form of particular solution is, okay, so for this term 2 to the power r, we'll write r to the power 1, because here the 2 is a characteristic root, that is a multiplicity of 1. So here m is equal to 1, so we have write r to the power 1. Okay, then here 1 is multiplied with 2 to the power 1, 2 to the power r. So 1 is a polynomial of degree 0. So we can write down the constant p1 with any constant p1, then this 2 to the power r. Okay, so this particular term is for this term 2 to the power r. Now come to this term. So this is a polynomial of degree 1. So we can write p2r plus p3. Okay, so it can be written as p1r 2 to the power r plus p2r plus p3. Let it be equation 2. Okay, put 2 in the left hand side of 1, we get, so to put it here in the left hand side of 1, so we get p1 r into 2 to the power r plus p2 r plus p3. This particular term is for ar. We come to minus 5 ar minus 1. So minus 5 is common here. p1 r minus 1 2 to the power r minus 1 plus p2 minus 1 plus p3. Come to last term plus 6 into p1 into r minus 2 into 2 to the power r minus 2 plus p2 into r minus 2 plus p3. Okay, so it can be written as p1 r to 2 to the power r plus p2r plus p3 minus 5. Let us simplify this one. So this one will be p1r into 2 to the power r minus 1 minus p1 into 1 p1 into 2 to the power r minus 1. Similarly, simplify the term. It is p2r minus p2 plus p3 plus 6. Open this parenthesis. We'll get p1 r 2 to the power r minus 2 minus 2p1 2 to the power r minus 2 plus p2r plus p2r minus 2p2 plus p3. Okay, so this is p1r 2 to the power r plus p2r plus p3. Now open this bracket. So this will be this 2 to the power r minus 1 is equal to 2 to the power r divided by 2. This will be 5 by 2 p1r 2 to the power r. Similarly, this minus 1 is plus. This one is 5 by 2 p1 2 to the power r minus 5p2r plus 5p2 minus 5p3. So this minus 5 is multiplied with this term, we get this. Similarly, we can have plus this one is 2 to the power r minus 2 is equal to 2 to the power r divided by 4. Okay, so this is 6 by 4 p1 r 2 to the power r. So similarly, this will be 2 to the power r minus 2 is equal to 2 to the r divided by 4. 6 into 2 is 12. So this will be 12 by 4. Okay, minus 12 by 4 p1 into 2 to the power r plus 6 p2r is 6 into this p2r minus 12p2 plus 6p3. Okay, now let us simplify this one. So we'll have p1r 2 to the power r minus 5 by 2 p1r 2 to the power r plus 3 by 2 p1r 2 to the power r. Okay, so in this case, all the p1r terms, p1r 2 to the power r terms are written at one side. Okay, at one place, p1r 2 to the power r. Similarly, you can write p1 into 2 to the power r terms at one place. So it can be plus 5 by 2 p1 2 to the power r minus 3 p1 2 to the power r. Okay, so this one is we have 5 by 2 p1 to the power r. Okay, plus this one is 3 p1 sorry 5 by 2 p1 to the power r minus 3 p1 to the power r. Okay, so this one is 5 by 2 p1 to the power r this term, and this one is 3 p1 to the power r. that is minus 3 p1 to the power this term. Okay, next we have p2r minus 5p2r plus 6p2r. Okay, so here all the r terms written at one place. Here all the r 2 to the power r terms written at one place. Here all the 2 to the power r terms. Here all the r terms. And the last is the constant. The constants are p3 plus 5p2 minus p3 minus 12p2 plus 6p3. Okay, so this can be simplified as, so let us take this r out of this particular term. So we'll get p1 minus 5 by 2 p1 plus 3 by 2 p1. Take this r and 2 to the power r outside this particular term, so we'll get r into 2 to the power r plus, similarly take out 2 to the power r from here, so we get 5 by 2 p1 minus 3 p1 into 2 to the power r plus, so this one p2r minus 5p2r this is equal to 2p2r. Simplify this one is 6p2r minus p2r is equal to 1p2r plus p2r is equal to 2p2r. Okay, similarly simplify this one, so we'll get 2p3 minus 7p2. Okay, so here we have p3 minus 5p3 plus 6p3 is equal to 2p3. Okay, then we have 5 plus 5p2 plus 5p2 minus 12p2 is equal to minus 7p2. So it is simplified as 2p3 minus 7p2 last term. Okay, so this is equal to, so see here this p1 plus 3 p1 plus 3 by 2 p1 is equal to 5 by 2 p1. Okay, so everything will be cancelled out here. So all these are cancelled out. Okay, so whole term is cancelled out here, and we have 5 by 2 p1 minus 3 p1 is equal to we have minus p1. Okay, to the power r. 5 by 2 p1 minus 3 p1 is equal to, say 2 will be LCM, 5 minus 6 p1. Okay, so 5 minus 6 p1 is equal to minus p1 to the power r sorry, it will be minus p1 divided by 2 into 2 to the power r, this one. Okay, so here 2 will be LCM, 5 minus 5 p1 minus 6 p1 is equal to minus p1 divided by 2 into 2 to the power r. Okay, plus 2p2r plus 2p3 minus 7p2. Okay, so this one is, let's suppose 3, compare 3 with right hand side of 1, we get minus p1 by 2 is equal to, is 2 to the power r, the coefficient of 2 to the power r is 1, so this is equal to 1. Okay, coefficient of r is equal to 1 here. So here the coefficient of r is 2p2. And the last is constant is 0. 2p3 minus 7p2 is equal to 0. Now let us solve this one. So we have p1 is equal to minus 2. Okay. And p2 is equal to 1 by 2. Because 2p2 is equal to 1. So p2 is equal to 1 by 2. So put the value of p1 p2 in this. So we'll get. So put the value of p2 here. 2p3 minus 7 into 1 by 2 is equal to 0. So we have 2p3 is equal to 7 by 2. Okay. And p3 is equal to 7 by 4. Okay. So hence the particular solution is of the form ARP is equal to, we have the form is P1R 2 to the power R plus P2R plus P3. So it can be written as, we have got P1 is minus 2. So this is minus 2R 2 to the power R plus P2 is half. So this is R by 2 plus P3 is 7 by 4. Okay, so it can be written as, minus R 2 into 2 to the power R, this is 2 to the power R plus 1 plus R by 2 plus 7 by 4. Okay, so this is the final answer we have, and this is the particular solution for the recurrence solution. Okay, so this much for today. Thank you.